Hello boys and girls, welcome to this video on the concept of the different modes of heat transfer. This video is being made for the purpose of grade 9 and 10 students of any curriculum, but specifically so for the IBMYP students. Alright, so before we could go into the details of the different modes of heat transfer, we need to understand what exactly is heat energy. And as discussed earlier, heat energy is in fact that form of energy which is always in motion from a body at higher temperature towards a body at lower temperature. Now, what are the different modes through which this particular heat energy can be transferred? From this particular diagram, it is quite obvious that there are three different modes through which heat can be transferred. One is conduction, convection, and radiation. Conduction, if you notice, is being shown towards the handle. Convection, it shows a few arrows moving up and then dropping down again. Radiation is always moving in the upward direction and is being represented with the red colored arrows. Eventually, we will try to understand the significance of each one of them. Right now, we already have done the concept of the kinetic theory of matter, which mentions that the entire matter is made up of either atoms or molecules, individual atoms or molecules, and these atoms or molecules, they are always bounded with one another. In the case of solids, the bond formed between these is pretty high. In the case of gases, the bond strength is very weak. Now, whenever we talk about heating a substance and trying to come about with an explanation with regards to how and why the body would expand or why the body would get heated up, we need to understand that whenever an object is heated, the particles present in that particular substance will gain more heat energy. By gaining this heat energy, the particles will now start vibrating more vigorously in the case of solids, or rather in the case of gases, the particles will now start moving at a faster pace. Either which ways, the particles or rather that particular substance will now occupy more space, as you can see in this particular diagram. Now, before we could further move ahead, let's try to understand the various reasons. Let me check if you can identify the reasons. Why does a metallic door handle feel cold when you touch it? Why do you think a saucepan has a copper bottom but then a plastic handle? And what could be the reason behind an aluminum window frame feeling colder than a wooden window frame when you touch it? You can pause the video for a bit right now, try to explore the reasons behind it, and the moment you're done, you can continue watching this video. Now, the reason in fact behind the three situations that have been shown is in fact conduction. What exactly is conduction? If you notice here now, there is a body at higher temperature, there is a body at lower temperature. Assuming that this is in fact a solid, and the spheres here being various atoms or molecules, the moment this particular body is heated, the particles closer to it will be able to absorb that energy, and because of that energy, they will be vibrating more vigorously with a higher amplitude. When they vibrate with a higher amplitude, they will now go and hit the particles next to them, because of which heat energy or rather energy is transferred to the next particle, and so on and so forth. As obvious, in this particular scenario, conduction is generally used to heat objects, or rather heating objects in the case of solids is explained through the process of conduction. We need to understand that in the process of conduction, there is no actual movement of matter as a whole. It does not mean that the particles do not move at all. It only indicates that the mean position of the particles would continue to remain the same. You will understand the significance of this particular statement when we also understand the concept of convection. Now, when one end of the rod is heated, as mentioned earlier, the particles at the heated end vibrate faster and pass on their energy to the particles all along the rod. IBMYP students, the moment you notice factors affecting, it means that this could be a probable criteria B question. What are the various factors affecting the rate of conduction? We need to understand again, we are not talking about how much energy is being transferred, rather we are discussing how much energy, how much heat energy is being transferred per unit time. It means we are actually dealing with power. Now, some of the factors, the material used is a metal instead of a non-metal. It indicates that the material, the nature of the material of the substance plays a very important role. If the material is a metal, the transfer could be faster. If the material is a non-metal, the transfer of heat energy through the process of conduction may not be that fast. The second factor influencing is the temperature difference across the ends of the rod. Now, how does this matter? Suppose this is a rod we are looking at. Yes. So, suppose this is a rod we are looking at. This end of the rod is being maintained, suppose at 0 degrees Celsius, and this end of the rod is at, say, 100 degrees Celsius. Now, obviously, from the hotter region to the colder region, there will be a transfer of heat energy. Now, suppose the amount of heat energy transferred per 1 second is a specific value. If I now increase the temperature of one of the substance, one of the sides, let me use a different colored pen, all right. Suppose this is at 200 degrees Celsius now, heat energy will continue to be transferred from the hotter region to the colder region. But then the rate at which, or rather the amount of energy transferred per unit time now will be much greater. I hope you understood that. And now the third factor would be the cross-sectional area of the rod. If I have a thin rod versus a thick rod, heat energy would be transferred at a much faster rate through the thicker rod. Try to identify the reason. The reason again here is pretty simple. When you have a thicker rod, it automatically means that there are more number of atoms present here, and so the transfer of a heat energy will be much more easier and smoother through the thicker end of the rod. And then finally, the length of the rod. The greater the length of the rod, the slower the rate of conduction would be. It means the thinner materials or thinner rods will be able to I'm sorry, it's not the thinner rod, it is about the length of the rod, right? So the shorter the rod is, the effective and the faster will be the rate of heat transfer. Having looked at the factors now, the first factor as we have identified are in fact the nature of the material. And I specifically mentioned that metals are good conductors of heat. What could be the reason behind that? All right, chemistry students, we all know that not every atom is stable. In order to gain stability, atoms would either try to gain electrons or lose electrons, or for that matter, share electrons. Metals are those substances which try to lose electrons in order to gain that stability. Now, the moment a metal loses the electron, what's going to happen now? The moment it loses the electron, that electron will be not bound or not bonded with any of the atoms and is now free to move all around the substance, and hence it is called as a free electron. In the case of metals, the number of free electrons would be on the higher side. Now, when the free electrons are on the higher side, you heat a particular part of the rod, the electrons will be absorbing that energy. They will now move faster, and there is every possibility that they could collide with the atoms or the molecules. The moment these collisions take place, the electrons will be transferring a certain amount of energy to the atoms or molecules. Through this methodology, heat energy can be transferred from one end of the rod to the other end of the rod. This is the basic mechanism, which automatically goes on to say that higher the number of free electrons, faster the rate at which heat energy can be transferred through the process of conduction. In case there are no free electrons, it automatically means that those materials are poor conductors of heat, or rather bad conductors of heat. As you can read from the list here, every single non-metal, or rather most of the non-metals, there are always exceptions, every single non-metal is a bad conductor of a heat, or rather a good insulator. Now, gases, in fact, are the worst conductors. What could be the reason? If you remember, at the beginning of this video, I clearly mentioned that conduction is the heat transfer mechanism often observed in solids. Reason here is pretty simple. In the case of solids, the particles are much more closer to each other. So at this particular point, if at all heat is being supplied, this particle starts vibrating with a greater amplitude and will start colliding with the neighboring atoms or molecules. During these collisions, energy is transferred, and this particle will also start vibrating more vigorously. In the case of solids, the particles are closer to each other in comparison to the gases. Now, even if I heat this end of the gas, even though this particle is free to move, it might not have enough amplitude to go and hit the other particle which is quite far away. Therefore, gases are considered to be the worst conductors. It therefore means that air is a bad conductor of heat. If you notice this carefully, the winters are approaching. We all will now move on to the woolen clothing. Wool is a bad conductor of heat. But why? Because it has trapped air within the pores of the woolen clothing. Now, how is it that we will be feeling warmer if we wear a woolen clothing? The concept is pretty simple. We all know that our bodies give out a certain amount of heat energy. When our bodies give out that heat energy, if at all we are wearing a woolen cloth or a woolen sweater, what happens is that the heat energy given out by our body will not be able to escape. Remember how wool is a bad conductor? Which means that heat energy given out by our body will stay within the wool and our body, and hence we will stay warm. So this is one of the applications of bad conductors of heat. They are pretty good insulators, remember that. Now this is a scenario where the insulation properties of these materials could be put to our use. Now suppose I have a hot water tank and I do not want heat to escape out of it easily. So what would I do? I would wrap all of this with plastic foam so that heat energy would not be able to escape. Having a glass or wool insulation in the loft would in fact ensure that heat energy would not get out of this particular region. Now, the heat energy that is present within, even if it tries to escape the concrete, if at all we are having a wall cavity with plastic foam or wool, or even for that matter air, would ensure this particular cavity would ensure that the heat energy will not be able to escape out of this particular room or house. Finally, think about a scenario where instead of having a single glass window pane, what will happen if at all we have two window panes with air in between? The moment there is air, it means it is a good insulator and the heat will not be able to escape pretty easily from this window. Right, I hope you identified the reasons. Now that we understood the concept of conduction, were you able to identify why a metallic door handle feels cold when you touch it? If you are still unable to, listen to the reasoning now. Metals we identified are good conductors of heat. Now, our body is always at a particular temperature, 98.6 degree Fahrenheit. Now, with that body temperature, if you touch the metal door handle, what's going to happen is that heat energy will be flowing from our hand into the metal door handle, and since the heat energy is escaping there, automatically the metal door handle will feel colder. But will it feel colder forever and ever? If you are in contact with that metal door handle for a longer duration of time, what's going to happen is that there will be a thermal equilibrium established. That is, your body temperature and the temperature of the metallic door handle will now be equal to one another. The moment that is equal, there will be no more transfer of heat energy. Therefore, at that point in time, the metal door handle will feel normal because there is no more heat transfer. How about this? A saucepan might have a copper bottom but a plastic handle. You certainly would like to have the content of your saucepan heated up, but while it is heating the content, you yourself would like to be on the safer side while holding the saucepan, because of which we make use of a copper bottom. Copper, being a metal, is a good conductor of heat, therefore it will be able to effectively transfer heat to the content within the pan. But then plastic is a good insulator, which means heat energy will not be transferred to the plastic handle, and hence you will be able to hold it much safely. Right, an aluminum window frame feels colder than a wooden window frame. Here there is a comparison being made between a metallic window frame versus a wooden window frame. Wood, we all know, is a bad conductor or a good insulator. Therefore, even if you touch the wooden frame, heat will not be transferred from your body onto the wood. Therefore, the wooden frame feels normal, while an aluminum window frame will feel much more colder. Now, two more questions with regards to why it is much safer picking up hot dishes with a dry cloth rather than a wet one. What could be the reason again here? The moment you are touching a particular hot dish with a wet towel or a wet kerchief, since it is wet, the water molecules present in that will be able to absorb that heat and immediately transform into the vapor state. Now that is a difficult scenario there. Those vapors can cause burns on your skin. Therefore, it is advisable to lift or pick hot dishes with a dry cloth. Wool and feathers are good insulators. No prizes for guessing the answer, because wool and feathers have air pockets within them. Air is a bad conductor. Therefore, wool and feathers are good insulators. A small little question, a reasoning question. So there is a rod which is made up of copper and wood joined together. The joint is being heated. There is heat energy being supplied. Question is, which point would be having the least temperature and which point the highest? Again, no prizes for guessing the right answer. The least temperature will be at the point P. The reason is again simple. There is a heat energy being transferred here, If there is heat energy being transferred over there, wood being a good insulator, heat will not travel to the far end. Therefore, the temperature at P will be the least. Now, copper is a good insulator. The heat that is being supplied there will eventually get transferred to the point S. But will the point S have the maximum temperature? The answer is a no. This is where heat is being supplied. So this is the point which will be having the highest temperature. Therefore, the point R will have the highest temperature. The right answer therefore is option B. Finally, we have comparing four thermal conductors. Now, from the figure, it is quite obvious that the examiner is probably asking you to come up with a methodology to identify which among P, Q, R, or S is the better thermal conductor. How do we go about it? Now, if you remember, there were a few factors affecting the rate at which heat energy can be transferred through the process of conduction. The first one is obviously the length of the rod should be the same. Now, these are your control variables. The area of cross section, all the rods should be of the same thickness. Temperature difference across the ends of the rods should be the same, because of which all the four rods, one end of the rod is kept in boiling water so that all of them have at least one end fixed at 100 degrees Celsius. Now, in this particular scenario, what will be the independent variable? We are talking about comparing four thermal conductors. Therefore, the nature of the material itself will be the independent variable. As mentioned in the diagram, he's talking about the presence of wax. Now, whenever heat energy is transferred, you pretty well know wax will melt. If a particular conductor is a good conductor, it means there will be a higher amount of wax melted in a given duration of time. Now, a control variable that has not been specified here, but then does play a very important role, is the duration over which we observe this particular experiment. Now, the rod in which the length of the melted wax is the most is in fact the best conductor. I hope you understood the concept of conduction. Let's meet again for the next video based on the concept of convection. Until then, goodbye.